Okay, so for question number 7, we have aqueous solutions of bleach and sodium iodide, and we need to write a balanced chemical equation, predict the products, and predict any experimental observations that we expect to see. So with this, we already know that the chemical formula for the bleach is Cl2, and the problem told us that it was aqueous solution, so we know that it's aqueous. And if we look at the second reactant, we have sodium iodide. Now, in order to generate the chemical formula for sodium iodide, we see that sodium, we know, has a +1 charge. The iodine has a -1 charge. If we cross these, just like we've been doing, we see that we get Na1I1, which you know is written as NaI. So we just generated the chemical formula for sodium iodide. So we have NaI, and it has an aqueous phase as well, as per the question. Now, in order to predict the products, we have to kind of look at this one a little bit differently. We can't treat this one like we've been treating the previous problems, because this Cl2 is what's known as a diatom. And it's called a diatom because it has 2 here. So diatom is actually not an ionic compound. So we can't treat this as we've done the other problems where we swap a cation for the other cation and anion for the other anion, because we don't have 2 ionic compounds in this particular problem. So generally what's going to happen here when this is the case is what you're going to see is you're going to see that the nonmetal of the diatom, so in this case Cl, is going to switch with the nonmetal of the other compound. So sodium iodide is an ionic compound. Cl2 is not. It is a covalent compound. So we have to do things a little bit differently than what we did in the previous examples. So what I mean by that is that this nonmetal Cl2 is going to switch with the nonmetal of the other compound. So when that happens, what we're going to see forming is we're going to have the sodium, which we know has a +1 charge, pairing with chlorine. And you know that chlorine has a -1 charge, okay, all by itself. So when we form this chemical formula, we know we're going to get, when we cross our numbers to get our new subscripts, we're going to get NaCl. So we have NaCl forming, and we know that this is aqueous. Okay. Now in terms of the other products, I said that it's switched. Well, basically what happens is you see that the Cl formed with the sodium. What happens to the other nonmetal, the I in this instance, is that it forms the diatom. So it becomes I2. And in terms of solubility, I2 is actually a solid. So it will fall out of solution as a precipitate. So we would have NaCl and I2 for our products. Now, make sure that you balance this, and what we see is that the chlorines are not balanced in this particular reaction. So we know that we have to put a 2 here, okay, and we have 2 chlorines, that's balanced. And now we have 2 sodiums, so we need to put a 2 here in order to balance it. And we double check, we have 2 chlorines on both sides, we've got 2 sodiums. Now we have 2 iodides on the left-hand side, but we also have them on the right-hand side. So now we have our balanced chemical equation. So again, this one's a little bit different than the previous examples that we've done because the diatom is not an ionic compound. But what you see is that the nonmetals essentially switch. So the chlorine replaces the I, and then the other nonmetal, in this case the I, forms a diatom. Now, in terms of experimental observations, you know that you are going to expect to see, because I2 is a solid, a precipitate of it. So we would see a precipitate of I2 when aqueous solutions of bleach and sodium iodide react.